Now we'll proceed with the problem. The earlier table was for converting the given problem into minimization problem. Now we'll write down the problem. That means once minimization, it is converted into minimization problem, the procedure follows as usual. First we will go for row operation, because we have already converted the given problem into a minimization problem. How we did that? By subtracting each element from the table, from the maximum element. So the maximum element has become 0. That means the maximum element has become the most minimum element. Likewise, bigger elements will become smaller elements, and smaller elements will become bigger elements. Once we make the allocation to smaller elements in this table, they will be assigned to bigger elements. That is the logic we will find here. And the row operation, as we know, we have to identify the minimum element of each row and subtract that element from all the elements of that corresponding row. Now we will see the 1 is the minimum element in the first row, because we have 16, 13, 7, 1, 9. So 1 is the least element. We have to subtract 16 minus 1 is 15, 13 minus 1 is 12, 7 minus 1 is 6, 1 minus 1 is 0, 9 minus 1 is 8. And in the second row we will see out of 10, 2, 9, 6, 4, 2 is the least element. So we have to subtract 2 from all the elements of that row. 10 minus 2 is 8, 2 minus 2 is 0, 9 minus 2 is 7, 6 minus 2 is 4, 4 minus 2 is 2, 17 minus. Now we will see for third row, the lowest element what we observe here is 2, 17 minus 2 is 15, then 10 minus 2 is 8, 8 minus 2 is 6, 2 minus 2 is 0, 5 minus 2 is 3. Then we will see the third row, out of which 4 is the least element. 10 minus 4 6, 12 minus 4 8, 9 minus 4 5, 6 minus 4 2, and 4 minus 4 0. And then the last in the last row we have 1 0. So we will write down the row as it is, because anything minus 0 will become the same element. So we have done row operation. Afterwards we will proceed for next operation, that is column operation. In column operation we will see the lowest element of each column and subtract that element from each of the element of that column, and we'll write down the table. Now we'll go for column operation. As we know, in column operation we are going to subtract the least element or lowest element of each column from that respective column. So we'll see the first column, we have elements 15, 8, 15, 6, 0. So when we subtract 0 from all the elements, we will get the same column, 15, 8, 15, 6, 0. Then the second column constitutes 12, 0, 8, 8, 8. That means the same, 12, 0, 8, 8, 8. Because 12 minus 0 is 12, 0 minus 0, 0, 8 minus 0, 8, 8 minus 0, 8, 8 minus 0. Then in the third column, we'll see we have elements 6, 7, 6, 5, 11. So in this 5 is the least element, and we have to subtract that 5 from each of the elements. 6 minus 5, 1, 7 minus 5, 2, 6 minus 5, 1, and 5 minus 5 0, and 11 minus 5 6. Then in the fourth column 0 4 0 2 7 are there, that means 0 is the least element, so we'll write down the column as it is, so there is no change in this. So then we'll see the next column, that is last column, 8 2 3 0 3. So we'll write down same, because 0 is the least element in this column. So once this is done, now this table is ready for allocation. Now what we'll do is we'll check for single zero rows. Now we'll go for this first row, 15 12 1 0 8. Okay, single zero is there, we'll make allocation here, right? As we have seen earlier in the problem, once we have made an allocation, we have to check for any zeros in the same column, and if there are any, we have to strike it. So here we will find 1 0, we will strike it off. Then we will go for second row. Second row we will see, and here we will find 1 0. Here this is 1 0, so we will make an allocation here. So here this is the allocation, because there is only single zero. So we'll check any zeros are there, no zeros. Here no single zero is there. Here two zeros are there, so we are not going to make any allocation. Here we'll see in the last row we'll find one single zero, so we'll mark it with a box, or we made an allocation here. This is done. Now we'll check for single zero rows. Check is over. Now single zero columns. Here no, here here we have one single zero row. So what we'll do is we will make an allocation by marking it with a box. So once a box is marked, then we have to check for any zeros in the row. Here we will find 1 0, we will strike it off. Then we check for next column, no zeros are there. But when we look at this table, we have only 4 allocations are there. Actually we require 5 allocations, but there are only 4 allocations made. That means this problem is not complete. So we have to proceed as usual, that writing that same, we have to take the same table and draw the lines such that they will strike off all the zeros. But the number of lines drawn should be as minimum as possible, and we should never draw lines such that all the rows and columns are striken off. Because if all the rows and columns are striken off, then there are no elements left for making allocation. That is the reason we should see such that we should improve the table further. So when there are elements which are not striken off, then we will identify the least element and subtracting from the elements which are not striken off, and that way we will write next table, and then we will again try to make allocation for zeros, like single zero row, single zero column, then double zero row, double zero column. Likewise we will proceed. So next we will proceed to draw the lines for the same table.